the last project that you mentioned is HACMS, which is a really neat project where the DoD said, okay, we recognize that we need some sort of foundational shift to build really strong security into our systems.
So just for the audience, it was a DARPA program.
Oh, yeah.
Yeah, so high assurance cyber military systems, I think is how it expands.
I think so.
Yeah.
And it was, and correct me if I'm wrong here, but there were sort of phases where they first wanted to build this little drone, the small quadcopter on the left, and then a full-size one that would carry people on the right there.
Yeah, the ultimate demonstrator was a full-size autonomous helicopter.
Yeah.
So a full-size helicopter autonomously flown. And not remotely flown, but autonomous.
But yeah, so the security problems or potential problems are pretty apparent here, that you have an autonomously flying drone. And so the effort was to see if we could develop these in such a way that they would be resistant to attack, like really resistant to attack. So a number of technologies were used, various formal methods, but AADL was used to specify the architecture because it has strong semantics that really don't leave a lot of ambiguity that can be exploited. And it worked. It was resistant to several weeks of red team attacks. They couldn't take control of it. I think at one point they found they could, disable logging temporarily or something. Some pretty low-level stuff. And that was even with the source code, the full design schematic. It's really a great success story of all sorts of cool software engineering research, including using AADL to get this rock-solid architecture specification.